Hello and welcome to the first video of the fifth section. In the previous section, we learnt about clustering with unsupervised learning. In this section, we will learn about recommendation engines, which produce a set of recommendations using either collaborative filtering or content-based filtering. Now we move on to the first video of this section, where we will learn to build function compositions for data processing. In this video, we're going to take a look at how to combine functions to form a reusable function composition. Also in this video, we will create three basic functions and look at how to compose a pipeline. One of the major parts of any machine learning system is the data processing pipeline. Before data is fed into the machine learning algorithm for training, we need to process it in different ways to make it suitable for that algorithm. Having a robust data processing pipeline goes a long way in building an accurate and scalable machine learning system. There are a lot of basic functionalities available, and data processing pipelines usually consist of a combination of these. Instead of calling these functions in a nested or loopy way, it's better to use the functional programming paradigm to build the combination. Let's take a look at how to combine these functions to form a reusable function composition. So in this video, we will create three basic functions and look at how to compose a pipeline. So let's see how to do this. First, we create a new Python function composition.py file and import these packages. Next, we define a function to add 3 to each element of the array, which takes input array as an argument. Now let's define a second function to multiply 2 with each element of the array, so the preceding code does this task. Then we define a third function to subtract 5 from each element of the array. After this, define a function composer that takes functions as input arguments and returns a composed function. This composed function is basically a function that applies all the input functions in sequence. So for the code, you see at line 13 and 14 is for function composer. Here we use the reduce function to combine all the input functions by successively applying the functions in sequence. Now we're ready to play with this function composer. Let's define some data and a sequence of operations. So we go ahead and add the code for this. If we were to use the regular method, we apply this successively, as this. Now use the function composer to achieve the same thing in a single line. So we can do the same thing in a single line with the previous method as well, but the notation becomes really nested and unreadable. Also, this is not reusable. You have to write the whole thing again if you want to reuse this sequence of operations. So here we are printing the output. Finally, let's run the code to check the output. So here we have two outputs. The first we obtained is through the lengthy way, whereas we got the second one using the function composer. In this video, we created three basic functions and composed a pipeline by combining functions to form a reusable function composition. In the next video, we will build machine learning pipelines with functions such as pre-processing, feature selection, supervised learning, and unsupervised learning.